warahmatullahi wabarakatuh and salam sejahtera. We are now in chapter 5 and the topic that covered in this chapter is gas power cycle, and we discuss about gas turbine plant. The subtopic in this chapter is about air standard assumption, simple gas turbine plant, which is Brayton cycle, and improving cycle performance, that is regeneration, intercooling and reheating. The objective of this topic is to evaluate the performance of gas power cycle, which is the working fluid remains a gas throughout the entire cycle, develop simplifying assumption applicable to gas power cycle, and to solve problem based on Brayton cycle with regeneration, Brayton cycle with intercooling, reheating and regeneration. So we go to the introduction of gas power cycle. Okay, Brayton cycle use air as a working fluid. It is classified into two main groups. First is gas turbine cycle. This is gas turbine cycle. And next is internal combustion engine or ICE. This is internal combustion engine. And this topic will be covered in chapter 6. Since this topic is a gas power cycle, therefore we have to have air standard assumptions. So what is the air standard assumption? We have four air standard assumption. First, the working fluid is all air, which behave as an ideal cycle. Second, all process in the cycle are internally reversible. Third, heat additional process is from an external source. And number 4, heat rejection process restore the working fluid to its initial state. The Brayton cycle represent operation of gas turbine engine. Okay, so it represent of gas turbine engine. This is gas turbine engine. The Brayton cycle is also known as a Joule cycle or constant pressure cycle, and it consists of 4 processes. Okay, the gas turbine consists of compressor, combustion chamber and turbine. And the process are 1 to 2 is isentropic compression in a compressor. 2 to 3 is constant pressure heat addition in combustion chamber. 3 to 4 is isentropic expansion. So when we talk about expansion, it must be in a turbine. And 4 to 1 is constant pressure heat rejection to the atmosphere. Okay, now we go to this slide. First thing first is pressure ratio. Pressure ratio represent with RP. Okay, so pressure ratio for this cycle usually up to 15. Okay, but it can up to 40 and more. Turbine inlet temperature, here TIT, can be between 900 to 1700 degrees Celsius. And temperature exit, turbine exit temperature, TET, the temperature is from 400 to 600 degrees Celsius. And the power that can be produced by the Brayton cycle is between 100 kilowatt to 300 megawatt. Okay, this is the comparison between gas turbine and internal combustion engine. Okay, we can see for for gas turbine, the fluid will enter at the compressor and straightly go to the exit. But for internal combustion engine, it will go through all this process. Okay, so this is compression process compared to the gas turbine. This is the combustion process and this is exhaust process. This is the example of stationary gas turbine, gas power generation, and you can see that the power plant or stationary gas turbine is very big. Okay, so we can see here, this is the compressor, combustion chamber, and gas turbine. Okay, and for gas turbine, it is used in a military gas turbine engine, low bypass ratio, and civil gas engine, high bypass ratio. And this topic, if you are further your study in degree, you will study about this topic.